the same thing. Rational numbers include all of the fractions and all of the integers. Irrational numbers are those things like pi, those things that go on and on and on. And all of those are under real numbers. Now, what category of numbers, I would ask you. You can see them all here. What group of numbers that we will use is not here? Does anybody know?
Imaginary numbers.
Yeah, so you guys did hear that, or did you just know that?
You went over it last time.
Good. Okay, so we did. So we had this, right? Okay. Why? Because 2 is certainly less than 3, and only one of these conditions have to be met because the conjunction between them is or. 2 is less than 3 or 2 is equal to 3. Since it meets one of the criteria, it's true. But if I wrote it like this, 2 is greater than or equal to 3, it would be false. Why? Because 2 is not equal to 3 and 2 is not greater than 3. Does that make sense?
Yes.
Yes.
Okay, Mariali, Miss Barrios, I've got you in. You're good. I got you logged in. Okay. Let's go back now. So all these things are you can pull in and use your brain and give the answers. Now, obviously, a -8 is less than 5. So that's true. Now, is a -8 equal to a -8? Yes, that's true. I mean, these are all examples that are going to be simple. Now, the hard ones, let me show you a little trick. This is a pretty cool trick. Somebody didn't really help me on this until and then when they did, I really liked this. This really helped me on text. So if I write this, Harlow Ramos, I got you, Gerardo. You're in. I marked you in, Gerardo. We're just still missing April and Guadalupe, the lawyer. All right. So if I have, let's say, 6/7 is greater than 5 over 6. How do you tell what the answer is on that? Well, the answer is you take this times this, which gives you 36, and this times this, which is 35, and so it's true. Because 36 is greater than 35. If I take 4 sevenths and 2 thirds, and I want to know which one's bigger, I take this times this, which is 12, this times this, which is 14. This 2 thirds is bigger, so this would look like this. It's a really cool thing to know, so you can quickly tell which one's the smaller or larger fraction. 4 looks bigger than 2. I would have thought 4 sevenths is bigger than 2 thirds, but you can tell that it's not. All right, I hope that makes sense. Let's go to the next page. Wait for that.
You have reached the voicemail box of 46947439495.
Well, that's not showing up right for some reason. So I can get my thing to work better here. Okay. It's not moving. There it is. I'll have to give you guys my special problem tonight. If everybody in the room gets it right, I usually give everybody an A in the course. Seriously. And I won't give you the problem until you're sure you can get it right. R7, come on, man. This is how they show graphings. Let me go to the other board and show it and make it a little better. So here, back here. Here we go. So look, if I say I want my answer to have 4 and all numbers greater than that, this is how you would show it in notation. Now, graphical notation, being this is 0 and this, let's say, is 4. You use a bracket, and it goes on, and you draw your line here and put an arrow. This is graphical notation. This is called interval notation. This is graph. I don't need to really write that down, everybody sees that. And then finally, you have set builder notation. Now, set builder starts out with a thing like this. It says all x such that x is greater than or equal to 4. So this is the 3 ways of showing the solution. Now, the book shows you sometimes this, which means it includes the 4. If it shows it like this, notice that it's not a bracket, it's a parenthesis. So graphically, it would look like this. And then go in infinity. Now, anytime that you involve infinity, infinity never has an ending and always has a parenthesis. Positive infinity is always on the right. Negative infinity is always on the left. Like that. All right. Let's see what we have here. Now, absolute values. An absolute value machine, I thought we went over this, but maybe not. The solution of absolute value, x equals 7, what does that equal? Can anybody tell me what x equals here?
X can equal to negative 7 and 7.
Yeah, it's positive or minus. Who said that?
What is that?
That is exactly right. It's plus or minus. There's always two answers. Now, if you have a problem that says this, there is no solution. The empty set. Now, the test will trick you, and I thought I'd mention this last time, but let's do it again. What's the solution in this case? Well, the solution in this case is plus or minus 3. And you're going to say, it's shown like this usually. Because the negative sign is here, you can get a negative. So be aware of that. So the absolute value of negative 7 is 7, 12 is 12, 0 is 0, and so on. You can see that. Can you look up and find out what page 8.5 is on, or R5 is on?
8.5?
R5, it just doesn't seem like it's getting us to the right spots. I mean, is there an R9 and an R10? It's not matching up. See, this is R1, but it goes R8. Well,
Did you say R9?
is there like an R10 or an 11? I mean, it doesn't
No.
seem like we're going to the right section. R5, exactly, it says equivalent algebraic expressions.
My R.7 says properties of exponents and scientific notations.
Page, that's R7.
It says R.7.
I'm not talking about the. I'm talking about the book. But is it the book that says that? What does the book say?
Yes, I'm in the Pearson book right now.
Yeah, I know it's my syllabus.
And that's that's page
What page is it
for R45. The properties of exponents.
R45.
Is that what you
Okay,
wanted?
that's what we need to go to.
Are you looking for the properties of exponents?
Yes. Actually, I'm looking for equivalent algebraic expressions. So that's got to be an R some page. Here, we're in
R32?
R10. Okay. Yeah, see, it's not very clear then. It should be, those are wrong then. So R10, let me just talk about this real quickly. Positive and negative signs. The rules are 2 like signs always means positive. 2 unlike signs means negative. So look, we have here 6 plus a minus. Now, the rule is two like signs not separated by a number always means add. 2 unlike signs not separated by a number means subtraction. Plus and minus are unlike, and they're not separated by a number, so it means subtraction. So you have 6 minus 8. That means you have $6 in your pocket, and you spend 8, you're down $2, and the answer is -2. That's a good way to remember that. 2 like signs, no matter what, as long as they're not separated by a number, means add. So again, you have 2 unlike signs here. You got a -13 and then a -8, gives you -21. -48 plus 31, you add them together. You have, in fact, the largest number is negative. Add 31 to it, you get -17. Just think about it. You owe a guy $48. You pay him 31, you still owe him 17. I always look at this stuff in terms of money. Now, the opposite or additive inverse. The opposite means if you have 7, the opposite of 7 is -7. When you add them together, that means you get 0. That's what it means. So, let's go to the next. That's pretty easy there.
Oh, Professor Wickman, it's blurry. Is there any way you can?
Yeah. Is this Lizette?
That's blurry for me. I don't know. It might be my network. No, it's blurry.
No, it's blurry for me as well.
Okay. I thought it was.
Let's try to go back to it. Sometimes this book has been. Can you see it better now?
We can't see it at all. Oh, now we can see it.
Yes, I see it.
Yeah. That's good.
Okay. So evaluate negative x, and this means number 13, whatever you add, it's going to equal to 0. Now, they give you 2 numbers, though. The 2 numbers are different. If you have 23 and then a -23, it's going to equal 0. So the opposites are the same numbers, but with different numbers. I mean, different signs. The numbers are the same, but the signs are different. So they always add to 0. So if I asked you, and this is going to be a waste of time, what's the opposite of -3? You're going to say 3. What's the opposite of -3/8? You're going to say +3/8. The opposite of 0 is no thing. There's no such thing as -0, but so the opposite of 14 is -14. Now, if this goes bad again, I'll try to stop it and we have it focused.
It's good.
Thank you. So now, again, you have 3 minus 5. The book sometimes is confusing, but again, think about it. You have $3 in your pocket, but you spend 5. Now that's me all the time. I always spend more money than I have, and then I want to know why about this time of the month I'm eating lots of peanut butter. Because, I spend all my money. And at the end of the month, I don't have anything left over. Now, some people are smart. They won't eat anything but peanut butter at the beginning of the month. At the end of the month, they can have steak. Anyway, just kind of kidding, but that's true. Multiplication. Let me give you a little table that will help. Let's see if it gets to that first. Probably will. All right. Let's stop this. It's probably blurry. Maybe not. But this is the table you should write down. A positive times a positive equals a positive. A negative times a negative equals a positive. Two opposite signs always equal a negative. And all these rules are true for division as well. That table you should write down. Two like signs give you positive, two unlike signs gives you negative. True for multiplication and division. Are we good with that?
Yes.
Yes.
Hopefully that's helpful to you all. Let me go back, clear this out. So we can go back to the book. So you have a negative times a positive here. A negative times a positive, everybody knows, is what? Two unlike signs, you're going to get a negative. Does that make sense so far?
Yes.
Okay, so we're just going to go on. The same is true for division. They're going to do that next. So we're just going to keep moving on. Lizette, you told me algebraic expressions was what page? R something or another?
Let me check. Did you say... Which one did you say?
Simplifying equivalent algebraic expressions.
Equivalent algebraic expression is R32.
Let me make a note of that here real quick.
Blurry again.
And what about simplifying algebraic expressions. Yeah, I understand.
That is page 439.
Algebraic expressions R6.
Let me see. This is simplifying algebraic expressions. R6
Yeah.
is page R39.
R39, okay.
Yes, sir.
And what about the last one, properties of exponents in scientific notation? All right, class, can you see this? Reciprocal of 5/4.
That's page R45.
Yes, you can see that.
Yes, we can see.
Okay, so all I want to was remind you all that the reciprocal means you just flip it. So instead of 5/4, it becomes 4/5 or vice versa. 1/8 becomes 8/1 or 1/8. And then of course, anytime you multiply them together, you're going to get 1. That's all they're saying there. So 8 is technically, number 39 is one of the trickier ones. 8 is technically 8/1. When you flip it, it becomes 1/8. Now, the reciprocal means you also keep the sign the same. So 40 is kind of tricky. When you flip it, it becomes 3/2, but it's still negative. But when you take a negative times a negative, it's a positive 1. So those are the only things you want to be careful of. Now, 0.25 is really 1/4. 1/1/4. This is what we call complex fraction. But think about it like this. The opposite of 0.25 in the bottom is like having 0.25 at the top. And anything over itself is always 1. So that brings me to like my trick question is, if I have 1/1, what does that equal to, class?
1.
What's 2/2, class?
1.
1.
What's 7/7?
1.
1.
1.
Now, what's an apple over an apple?
An apple.
An apple.
Apple.
No. Anything over itself is automatic.
1.
Right.
1. Okay.
Oh, one apple.
Yeah, no. It's just 1.
One.
Let's see. I know. I hear you, Matthew. You be sure to mute that now. All right, but that's good. I like that. That means you're thinking. All right, let's see if we can get there. All right, can you see this now?
Yes.
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 Is it clear?
Yes, it is.
Yes, it is. Okay. Now, this one, you should really have your calculator. Seven to the third power. Did we show this on our calculators the other class by chance?
No.
Okay. All right. So look. And this is doing this. See if I can make it do something unique. I will then go to I will show you one of the problems that I give on the test, and people get this, believe it or not, in other classes get this wrong all the time. So I give them this problem on the exam. I say, what is the answer to this? And they give me this answer. What are your thoughts?
It's a 9.
Yeah, this is not right.
Yes, 9. 3
No, it's not. No.
It's 9.
It's not.
Yeah, it's 9.
Yes. But people will do this all the time because they don't know. In my other class, especially. Yeah. Also, in exponents. What does that equal?
0.
0.
It equals 1.
No, it's 0.
Oh, 7?
We have 3 different answers here. I'm confused. Let me go to my calculator once. Maybe that will help.
Yes, 7 times 0.
Let's
Pretty sure
see. Ah, 7 to the 0 power is 1. Already done. Let's do it again. Are you guys getting this? Can you see it 0?
Yes. Yeah.
Okay, so just for a quick second here, who is my video person for this class? Anybody? Is that Josue? All right, Josue, I need you to. It has Jose Rodriguez contacted you. Can I give him your number if that helps him? Or do you have your information on the chat? Yeah, okay, he won't bother. He's not really. It's a different guy. But look, anything to the 0 power is 1. So I want to emphasize for you all in this class, if you cannot attend this class, you just call me in advance and say, Dr. Wick, I'm going to be late or can't make it, but I'm going to watch the interview, the video for the class. I've spoken with Jose Facundo, and he's going to make it available to me, and I certify I'm going to, something like that, that you're going to do it, and I'll give you credit. That took about 15 seconds. That's all you got to do. And then, of course, I trust you. I mean, this college, I trust you.
I think Jose either made a YouTube subscription.
I don't know. We did. Wow. Good deal. That's good. Thank you. All right, so let's look now at this. Negative exponents. I have to talk to you specifically about these. A negative exponent cannot exist. So I have 7 to the negative 2 power. That is in fact a number, but it is not properly written forth in accordance to mathematicians. That would be the same as saying 7 over 1 to the negative 2 power. That is not allowed to be said like this. What happens is this exponent will become positive if it crosses the line. So 7 to the negative 2 power, in fact, is 1 over 7 squared, narrow left, which is equal to 1 over 49. Everybody see that? You cannot have a negative exponent. It's on your test. So if I have 3 to the negative 3 power, what does that equal to? Well, that is in fact equal to 1 over 3 cubed, which in fact then is equal to 1 over 27. Does that make sense?
Yes.
Yes.
Good. If you understand what I just did, then this next problem should work for you. You would write that as, Jose, you left, Jose Facundo. You'd write 3 to the third power over 5 to the second power. By the way, I see that when everybody leaves, though. So 5 to the second power is 25. 3 to the third power is 27. That equals this. All I did was flip it. The 3 goes to the numerator with a positive exponent. The 5 goes to the denominator with a positive exponent. Does that make sense to you guys?
Yes.
Let me go then.
Yes.
Let me go forward. Now you can see they've done the same thing here. 1/2 to the negative 3 power in 19 is the same thing as saying 1 to the negative 3 power. I mean, I don't like how they did this. This is like, let me do 19 for you too. Well, look, at 20 is easier. 2 to the negative 2 power flips down below. And let me just do them for you. 1/2 and 2/5. Just remember that. Both 1/2 is to the negative 3. I'll just write that down. I don't like the way the book shows it. Pretty confusing. I'll show you the way it should look. You have 1/2 like this in parentheses to the negative 3 power. That's the same thing as saying 1 to the negative 3 power over 2 to the negative 3 power. Now we know they can't be negative, so they have to flip. So it becomes 2 to the third power over 1 to the third power. 3. 2 to the third power is 8. 1 to the third power is 1 times 1, that's 8 over 1, which then gives you 8. That's how it should be shown. And that makes much more sense. Does that make sense to you guys?
Yes.
Yes.
So all I did, I took away the parentheses and rewrote it to look like this. Now, once you have it like that, you know you cannot have negative exponents. They have to flip. So the 2 comes up on top, and that's a horrible looking 3, but that's what it is. Same here. 2 to the third power is 8. 1 to the third power is that? 1. Well, you can see that now. Let's go back to the book. Let's go to the next page. Actually, we need to go to R32. Equivalent expressions, values, and so on. Let's see. All they're doing here in example 1 is telling you that in the equation you have x plus 2 plus x and x is equal to negative 2. You just put in the negative 2 for the x. So in the very first block that's empty, you have a negative 2 plus a negative 4, which gives you negative 6. You can see it right here. All you're doing is plugging in the negative 2 for the x. In the second one, you're putting 5 in there. So 5 goes to x plus 10 gives you 15. All you're doing where it says value is plugging in the number for the x. So obviously 0 plus 2 times 0 is 0. 3 times 0 is 0. Anyway, that's all you're doing is plugging in the x. Pretty easy. R33 is all done. So that was really helpful for you to give me these.
You're welcome.
Thank you. All right, number 2. Again, we're plugging in information. Use multiplying by 1 to find an expression equivalent to 3 over 5. Now, this is another terrible, terrible example. 3 over 5. So let's just go. Let me just tell you this. An equivalent to fraction 3 over 5 means whatever you do at the top, you have to do at the bottom. So they multiply the top by 2x, and they multiply the bottom by 2x, which gives you 6x over 10x, which is equivalent. Why? Because you can cancel. What I would have done is multiply both of them by the 2. The x part is confusing. So you have 2 times 3, which would give you 6, and 2 times 5, which would give you 10. So that's how I would start out. Number 3 takes it to another level. Simplify. Well, the rules are, again, whatever you do at the top, you can do to the bottom. So I cancel both the top and the bottom, and you're back to 7 over 9. Boom. All this other stuff is just, I don't know, confusing. Again, if you can take away the x on the top, you take away it on the bottom, you get 7 over 9. That's equivalent. Okay, see if we get anything new here. If not, we're going to move on to R39. Okay, so look, evaluate x plus y, and they give you numbers. Now, if you put, by the way, the rule, again, this is not very good. For sure, this is not good. Anytime you substitute a number in for an x and y, you must use parentheses. Later on, the book will tell you that. I don't know why they don't here. It makes a difference. Not in this problem, but in future problems, it does. So, it tells you x is 5 and y is 8. You plug it in. X is 5 and 8 is 13. It's just too simple. We're going to move on now. We're going to go to R39, I believe. Now, this is this is what we call combining like terms using the distributive property. So you have 3x plus 5x. Notice that in each of these you have an x. So if you factor out the x, you still have the 3 plus 5, and then you get 8x. Well, look, everybody knows that 3 apples plus 5 apples gives you 8 apples. If you don't use x's, call them apples. Number 2, you can factor out the x. So if you factor out this x, you get a 1, and you get a minus 3. Now here's what happens. The x is factored out in number 2. So if you take x times the first one, you get the x. If you x times the negative 3, you get the negative 3x. Now, let me, again, show you number 3. Let me show you number 3. The way it should be shown. Better, I'll make it make better sense. You probably understand it anyway, but some may not. So let's look at this one. So the book gives you this. They say, okay, you have 2x plus 3y minus 5x minus 2y. Now, what you need to do is combine the x's and the y's so that you can factor them. Notice that you have an x here and an x here. So we're going to say 2x minus 5x. We're going to put those together. And we have a y here and a y here. So that gives you a plus 3y and a minus 2y here. Now we're going to combine these two and these two. I can factor out of x of these. So that would give me an x. I have in parentheses 2 minus 5. I'm going to combine the y's here. It's going to give me 3 minus 2. Now, 3 minus 2 is in fact 1. This 2 minus 5 gives you a negative 3. So the answer is you have a negative 3x plus 1y. That's how it's supposed to be shown to you. Now, this is a complicated thing. Most people know that 3y minus 2y is 1y. You don't even really need to factor here. This is just the way they're teaching you how, it's setting you up for the future. But 3 apples minus 2 apples gives you 1 of them. Now let's go back to what they do. They just made it complicated. Don't
Professor,
let it...
forget
Yeah.
the x, the negative 3.
Right here?
Yes.
Yeah, you are right. Good catch. All right, let's go back. I like that. Next page. See, they get the same thing we said. But they're teaching you should combine like terms. Notice that if you have negative 3x like in number 10, you simply can put the negative sign without parentheses. It looks like that. 11's the same way. 2 like signs, not separated by a number, means positive. Boom. Number 12, if you have a negative sign outside of parentheses, that means everything inside changes. So 4 becomes negative 4 is in the bottom. X becomes a negative x. Boom. All right. We're going to go now to R45. And I skip a little bit of time of stuff here because I made a commitment to this group to try to get you out at 8:20. That's what we decided on. I want to try to keep by my stuff. And so there are little things that we're missing. Hopefully you'll be able to catch up on that. Properties of exponents in scientific notation. Look at this. If you have the same bases, you add the exponents. So x to the fourth times x third gives you this, x to the seventh. Let me make that clear for you. Let me show you this. If I say I have x to the second power times x to the third power, you don't get x to the 6, you get x to the 5. Now, why is that? Well, x squared means you have 2 of these, and you're going to multiply it by 3 more. 1, 2, 3. You add these up, you get 5. That's what it means. You add these numbers. Boom. Not multiplying. So now, they make it more complicated. Let's look at number 5. You have 8x to the fourth and y to the negative 2 power. Well, y to the negative 2 power, it has to go in the denominator. So let's look at this first. But let's just take the whole numbers first. Don't let this bother you. Let me break it down for you easy. 8 times a negative 3 is negative 24. And that's what you see in the next line. X to the fourth and x to the negative 3, you add them. 4 minus 3 is 1. You got x by itself. Boom. Y to the negative 2 and y means you have a 2 and a 1 gives you a negative y. So y, since it's negative, just goes in the denominator. That's easy now. That's what this was all about. Changing that exponent to negative to the denominator. Now, let me give you another problem. Let me give you the second part of this class where I teach scientific notation. There are 4 rules for scientific notation that I have given you. I want you to write these down. Rule number 1, your number has to be between 1 and 10. Between 1 and 10. 2, the number has to be times 10. 3, the exponent equals the number positions you move the decimal. Number 4. By the way, I just want to explain, some of you guys may not know this. Can you still see me a little bit?
Yes.
Yes.
I don't know if you can see this, but during the military, I got hurt. My right arm was cut off. It's sewn on right here. It's re-sewn. All that is scar. You can't really see it real well right now, but I could sometime I'll blow it up for you, but that's for sure. So when they reattached it, they had to rebuild it with parts from my leg. Well, I don't write very good. Same thing with my thumb. You can probably see it's all messed up. You can probably see some of the scar tissue. It's my other thumb. It's normal. So you can see it. See, it's regular thumb. Works good. This one won't even open all the way. So I got hurt pretty bad. Back has got meddling and stuff. So I tried to write good. So I want to just kind of throw that out for you so that you know I'm trying to write. You know, I'm doing lots better than I used to. So you're going to say, oh, good gosh, and he was really bad. I was. So anyway, rule number 1, the number is between 1 and 10. 2, you have to take that number and times 10. 3, the exponent is equal to the number of the positions that you moved the decimal. And if you move the decimal to the right, it's negative, and went to the left, it's positive. Now, if you wrote those things down, I will now explain it to you, and I will give you my quiz. And if you get the quiz right, you're free for the day. But not everybody gets it right. So everybody have those written down?
Yes. No, give me a second.
This is very important. Are we good?
Yes.
Yes.
Okay, be sure to mute. All right, so here we go. I'm going to give you a problem now and work it through with you. Now, I want this number 0.123 written in scientific notation. So rule number 1 says the number has to be between 1 and 10. So to make this in scientific notation, I'm going to move this decimal 1 position because now it is between 1 and 10. Everybody agree with that?
Yes.
It is.
Yes.
That's rule number 1. Rule number 2 says to do what?
Times
Round?
10.
Or
So we're going to multiply times 10. How many positions did we move the decimal?
1.
1.
Yes, one.
So is the exponent positive or negative?
Move it to the right. Positive.
it's negative.
The answer. Let's do another one.
It's negative.
So let's do another one. Let's do 27.652. I'll do 127.652. Be sure to put your phones on mute now. So rule number 1 says you can rewrite this thing to make it scientific notation. You have to have the number between 1 and 10. So we got to move this decimal this time this direction. So we have now the number 1.2765, 2. Rule number 2 says times 10. How many positions did we move the decimal?
2.
2.
Is it positive or negative though?
Positive because you moved
Positive.
Positive.
And you would be 100% correct. That would be your answer. Are you guys good?
Yes, sir.
Yes.
Yes.
Yes, sir.
No.
Yes.
Let's do a couple more because I don't think you are good.
Oh,
Let's
sorry.
do one more. Maybe you are. I want that number in scientific notation. Somebody tell me what to do first.
First, you're gonna move it 1, 2, 3, 4 places to the right.
So we're going to move it to here. Is that what you're saying?
Yes, sir.
What's the number now?
It's gonna be
5.2.
Next step.
times 10.
Then you multiply by 10.
What's
And
the
then-
exponent?
It's gonna be negative
4.
4.
Negative 4, yes.
Negative 4.
Good with that.
I'm sorry?
You good?
Yes, sir.
Yes.
So
Yeah.
that number equals this number in scientific notation. Now let me tell you, I'll give you the trick problem, right?
Okay.
Now what I normally would do, which I won't do now, but I should have, is if you got it right, I give you an A for the course if everybody got it right. I give everybody an A for the course automatic, but not everybody will get it right because it's a trick one. Are you guys ready for this one?
Yes.
Now in my class this way. I want this number in scientific notation. Write that number in scientific notation. Somebody tell me. What do I do?
Since it's already
7.7.
less than 5, then or less than 10, you leave it the same, right? And then you just put times 10. But I don't know, would it only be just 1 up to 1 because it's still at the...
How many positions did you move the decimal?
We didn't move it at all.
Where is that? Where is that?
0.
Exactly. And anything to the 0 power is what?
1.
So this is 7.65 times 1, and you would be 100% right. See you guys. Any questions of me?
No. No.
You guys did good today.
But wait, 7 times 1, what does it equal? Just 7.
Yes.
What's 1 times anything?
Yeah,
Yeah.
0.6.
Same number. 7.6.
Same number.
Don't let math fool you. You just told me the answer. I'll give you another smile. Bigger. All right, guys. I'll see you again. When do I see you all again?
Monday.
Monday.
Okay, now I just want to make sure. Samuel Green has not been here at all. If anybody knows him, contact him. Guadalupe, my lawyer, she's not here. You've seen it. And April Sierra has never been in. Is that right? Okay, if you know any of those people, tell them we're missing them. See you later, guys.
Okay, bye.
Bye.
Bye, Professor.
Thank you so much, Professor.
Bye.
Good group. Be safe. Be safe.
Okay, you too. Bye.
Hey, what a good group this is. This is a good group.
Let's